Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is NoSQL and Business Intelligence. This is the first session in the Business Intelligence series that we have started conducting, and it would be going on in the coming months. Our guest speaker today is Mr. Kalyan Venugopal Abaraju. He's a staff engineer at VMware India. He has overall 13 years of experience in architecting, designing, and building enterprise-class scalable distributed systems. Mr. Kalyan has also worked in telecom OSS and enterprise IT domains. He has extensive experience in SOA, BPM, business intelligence, big data, product and solution serviceability, and constantly evangelizes new technologies. Currently, his prime focus is on improving serviceability of products by analyzing large-scale diagnosis data originated from multiple product deployments. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Kalyan.
Hi. Thank you, Mohini. So I hope you can see the screen now.
You can.
Okay, thank you. So hello everybody, good afternoon. First of all, I would like to thank you for joining in this webinar, NoSQL and Business Intelligence. Thank you for this interest. So it's such a great pleasure for me to be here and present and share my thoughts in front of such a big crowd. Special thanks to TechGig Group for providing me this opportunity. Okay, so coming back to this webinar, so basically I try to also cover up some of the aspects of general aspects of NoSQL and as well as also BI, and also primarily focusing on the NoSQL and Business Intelligence. So let me get this started. So let me start this with the agenda for the rest of the hour. So the agenda basically primarily initially I will be focusing on the BI architectures and also the challenges in BI and as well as the traditional SQL, and also a little bit of trends going on in the industry in the area of NoSQL and BI. And post that I will be focusing on the NoSQL overview just to get started with respect to the NoSQL. And the last two sections I will be focusing on the integration patterns of NoSQL towards the BI and as well as also SQL modeling patterns that we need to follow in the business intelligence. So let me start the first one, the BI overview and architecture. So here, so basically if you look at the architectures that are presented over here in the slides, so this is the most simplified architecture of the BI. And since we need to look at in a holistic perspective, so I try to create 3 layers. One is the data sources, the bottom layer is the data sources, and the middle layer is talking about the warehouse, and the top layer is the business intelligence. So the data sources can be of any kind of data sources ranging from providing a set of flat files and as well as also data sources, something like relational database systems, or it can be some different kind of applications which actually talk with REST or web services kind of protocol or any legacy protocols which actually offer the data to the business intelligence. And the warehouse is the crux and core of the business intelligence, which actually stores this information and also does the processing that can be presented to the BI users. So in the warehouse, we have an operational data store, which primarily actually stores the transactional data and the data marts, which basically departmentalized, and this means that each department can have its own data mart or multiple data marts to actually facilitate the use cases of that particular department alone. And if you look at the business intelligence layer, we have the BI applications. The BI applications are the one that provides the data related to that provides information in the form of reports, dashboards, and maybe also in the form of some kind of exploratory data analysis. And below that we have semantic models, which primarily the modeling of the entire warehouse and giving a consistent view of the data. And the most importantly, these semantic models will give the business taxonomy to the data that is residing in the database. So basically, for example, if you have a database column called author_ID, so for the business users, author_ID does not make sense, so it will be suppressed. And if you have a column name author_name, for the business users, this can be converted into author name. So such kind of technical to business taxonomy can be also done by semantic models. And along with that, we have a BI repository, which is primarily focusing on storing the BI artifacts. That means the reports, the dashboards, and also any other, let's say, collaboration related information, scheduling related information. All this info will be stored into this repository. And then we have a query engine, which is primarily generating the queries or building the queries according to the target data sources. For example, if the data warehouse uses RDBMS, Oracle RDBMS, it can generate the SQLs that are more optimized for the Oracle, and also execute them against those databases. So holistically, this is the stack of BI. So I will get on to the next phase wherein we talk about 6 steps in 6 key steps in making a business intelligence project. Of course, these steps does not talk about, let's say, collecting the business intelligence requirements, etc. But these primarily will focus on how do we actually build these individual layers. So if you look at that, the first one is the data sources. So we need to look at preparing the data sources, which means that we need to understand what kind of data sources are relevant for this business intelligence application, and also how to get this data from the data sources, whether it can be a file streams, or it can be a file systems, or it can be OLTP data stores, or any other data marts. And then next step includes the data rationalization, wherein we talk about, for example, how do we access this data, whether we do a direct data access, or we do a federation of the data sources, or do we actually, what kind of filtering that we wanted to do on the data. For example, whether it can be filtering, enrichment, aggregation, and correlation kind of processing on top of the data. And the next one also talks about, do we need to do any complex event processing on the data in order to fulfill the needs of BI. And do we also get some kind of text sources? Do we need to do text analysis, natural language processing? And also this talks about what kind of data quality analysis that we need to do, what are the SLAs. So, and the last but not the least, how do we actually govern this data? So this includes the data retention, this can include the data security, all of these aspects which help us to rationalize the entire data in the database or data warehouse. So the next step is primarily the building the database warehouse itself. So here we talk about the warehouse building or analytical database building or a data mart building. So here one of the primary element is identifying the staging area requirements. So how do we actually build the staging area? Do we require a file system? Do we require a database? What is the retention policy for this kind of database? How do we actually load the data into staging area? And how do we actually fetch the data from the staging area into a warehouse? And the second one talks about operational data store. So primarily this is a storage for transactional real-time data, wherein we keep this data highly granular in nature, which can be later on subject to aggregations or summarizations. And as part of this storing the data in operational data store, we can also perform some of the basic data processing also, that includes, for example, filtering and enrichment of the data, and also looking at redundancy in the data and how do we actually relate one database table to the other database table. So all these aspects we can look at as part of the operational data store designs. The next one is the data warehouse itself, wherein primarily we focus on creating a pre-aggregated data storage. So this means we have to look at what kind of aggregations that we need to do, what kind of summarization, data summarization that we need to do, and also to what levels, what are the dimensions that we need to use in order to do this aggregation, and what kind of correlation that we need to do between, let's say, two fact tables. And the next one is the data marts, wherein we focus on specific use case of a department, and then try to build the necessary data structures as part of this data mart. And the OLAP cubes are materialized views. So here we talk about giving a multi-dimensional query capabilities for the data warehouse by introducing OLAP cubes or materialized views in the system. The next one we talk about building a semantic layer itself. As I mentioned in the past, the semantic layer is actually giving is a kind of front end to the end users, which is actually doing the translation of this technical data structures into a business-friendly objects. And also it understands how do we actually navigate across various aggregation layers. How do we actually understand the dimensions? How do we link the dimensions with each other? So all those things we can actually model, and then we can present this as a for end users to create reports and dashboards. The next one is the business intelligence artifacts itself. The artifacts include schedule or ad hoc reports, dashboards and drill down, and data exploration domains. Basically, when we talk about data exploration, we might have terabytes and petabytes of data in the data warehouse. So we will not be able to explore the entire data, let's say, from a single console. And we will not be able to actually make a meaningful data if you have too many parameters in the warehouse. So here what we try to do is we create independent logical domains, and each domain is giving a subset of data. And the data exploration analyst can actually look at the independent domains separately and then try to analyze the data and find out the patterns from the data. And then the performance management, so wherein we talk about the key KPIs that needs to be part of the business intelligence and monitoring those KPIs. And then the next one is the predictive analytics. Of course, this is where we talk about what kind of predictions that we want to do, what are the business problems that we need to solve as part of this. All of the models, the predictive models, will be part of these artifacts. The next step is the publishing and delivery part. So here we talk about how do we actually publish this BI information artifacts, in what forms that we publish. This can be forms like, for example, Word documents or PDFs, or this can be in the form of delivery channels like portal, wherein the user can log into a portal and see the list of reports or dashboards, or the email delivery of those reports, or the mobile delivery of the reports, or it can be Office apps integration itself, wherein users can integrate the BI reports or dashboard directly into their Office documents, and then view the documents in real time from the Office document itself. And then alerts, wherein we are talking about basically integrating, wherein we talk about identifying the KPI thresholds or breaches, and then send the alerts to target systems. And then actions, so in case of findings of those breaches, KPI breaches, we need to also trigger certain actions so that we'll be able to complete the, we will be able to fulfill the needs of the BI by performing certain actions. And then the next one is the collaboration. So here we talk about how do we collaborate between the BI users, and then how do we share this information, let's say the BI artifacts, and also how do we improve the BI processes, optimize the BI process by collaborating. So all of them should be part of the publishing and delivery step. So all the 6 steps are very key in the business intelligence, though of course we can have some more supplementary steps which will help us to get a good BI project. The next one talks about a more comprehensive or full BI stack that is published by Forrester a few years ago. So here the Forrester talks about multi-layered stack, wherein he talks about Forrester talks about the infrastructure as the bottom layer, and then you have the data layer, wherein we talk about various kinds of DBMS systems, the OLAP, and then XML kind of storages or hierarchical kind of storages, and in-memory database management systems. which contribute to the BI. And the next one talks about the discovery and integration, wherein we talk about the data management and data integration, and as well as the data discovery. So then the top layer, the above layer, talks about the analytics, where we talk about the mining and as well as the guided decision making, natural language processing, time series analysis, these kind of aspects. And then we have some kind of supporting applications which are very important. That is collaboration, lifecycle management of the BI, and also enterprise content management and master data management. And on the top we have the performance management, wherein we talk about tracking the metrics, planning the metrics, and then the scorecards. And then on the above we talk about reporting. Here we talk about the dashboards, advanced data visualization, and reporting, ad hoc reporting, alerts, all these components. And then the top we talk about the delivery. So here we talk about how do we deliver this reports or dashboards to as a desktop gadget, or to portals, to office applications. If you see on the right hand side, we have also a list of supporting elements, components with respect to the BI project. One is the external apps, which includes the enterprise applications and as well as other industry applications. And also it talks about how do we actually deliver this BI as such, so which is basically a software as a service model, or it can be a hosted BI. And then a professional sales office, which talks about the center of excellence, and also talks about MSP. And the most importantly, we need to have governance and methodology around the BI in order to have a successful BI project. And now I will be talking about some of the challenges that we see in the typical BA project. So generally the BA projects run a longer period of time, few years. So one of the major problems that everyone faces is that the BA change, the needs, the requirements will move faster than BA application development itself. And that is, this means that it also puts an imperative requirement to us that we need to be fast enough to develop the BA application. And historically, BA was also almost never plug and play. So if you have to integrate new data sources, there is a huge amount of process in terms of, let's say, understanding the data of the data source, and as well as also modeling the data into the data warehouse, and also creating the loading procedures, and then defining the aggregations, defining the semantic layers, and as well as also creating the needed necessary reports and dashboards. So the plug and play is not trivial, and generally even introducing a new data source typically takes a lot of time. And then the most importantly people talk about is the real-time and right-time intelligence. So the real-time intelligence is the one that we talk about giving the instant intelligence results, the BI results on top of the data. And since BI stack is typically oriented historically based on a data warehouse, and which generally wherein in the data warehouse we try to load the data once in a day or once in a few hours, so which is not real-time in nature. But the demands have been changing, and we have to be acting in real time and actually do the analysis on top of the incoming stream directly. And the right time intelligence primarily talk about giving, let's say, performing the actions or giving the analysis on the KPIs in the right time. I mean, we're not talking about immediately giving the results, but actually giving the results in an appropriate time. And also the real-time search of intelligence. So the search is one factor that is almost missing in the BI tools, the old traditional BI tools. So we should be able to search the data fast and then get the results, and then so that we can create some patterns out of the data. And data visualization challenges. So data visualization is not anymore creating bar chart or pie chart or those few 10 different types of charts into reports and dashboards, but people expect very intuitive or interactive charts which will help to understand and also analyze the data very fast. So there are very challenges in the data visualization also, and also the reachability of the intelligence. So typically we tend to, when we have a BI deployed, we tend to have one portal, and this portal is offering the services, but the amount of data delivery channels have been increasing a lot in the past. So we need to deliver the business intelligence to mobiles, we need to deliver the business intelligence to other kinds of, let's say, office applications, and even other kinds of services like desktop gadgets, which is not there in almost not many of the BI tools. And also we are also basically the BI tools are as the number of let's say the tenure of the BI increases, the data is also increasing very heavily, and especially with the involvement of social data into the BI, the data volumes have been increasing very heavily. So the scaling issues are prominently seen in the data warehouses that are developed long time back. So we need to have a change in the architectures in order to accommodate this new kind of data. And then the other challenge is we should be able to offer BI as a service or a self-service BI, which is also posing a different kind of challenges because the consumers are varying nowadays. In the olden days, the consumers of a BI is typically one particular department in the enterprise, which actually looks at this creation of the reports and dashboards, and then deliver these reports and dashboard to various other departments. But here, each and every user actually directly are using the BI, and the amount of user support for a BI tool also has been increasing heavily. And then also we have now varied kind of user bases. Here we talk about executives, engineers, researchers, marketing, and sales. Earlier the BI is primarily meant for executives and some high-level managers and marketing engineers. But I think the others are not looking much into those BI. But I think nowadays the trend is such a way that even the other engineers and are in the recipients of the BI. So, and then most importantly, the more interactivity and cognitive intelligence. So which means that the BI tool should be able to understand the user patterns and able to give the sufficient information for making the analysis. So these are the various kinds of complex challenges that the current BI users are facing. And now traditionally the BI is based on SQL, so I also try to put some kind of SQL challenges that we had faced with respect to in the BI projects. So basically the SQL databases, the regular relational database management systems, are difficult to scale horizontally. So most of the times there is no dynamic scaling at all, and of course the recent DBMS have a lot of change, but most of still the process of scaling is pretty weak, and also the scaling factors. So it's not going to be any more linear scaling. So we are not getting the benefit in terms of the scaling. And the complex schema management. So the schema itself, because relation tables requires too much of schema, and the schema itself is becoming very complex. And the monitoring and management migration of this schema is becoming very difficult, because it's very hard, rigid, the relation database will contain the rigid database schemas, and it's hard to actually migrate them. And then the data integrity sometimes becomes an overhead. So because sometimes application level data integrity gives us more flexibility compared to the database level integrity. So there's in this way the data integrity, relation level database level data integrity is becoming a huge overhead. And the joins are becoming very expensive. So especially database level joins are, in fact, if you have to do two large fact tables, the join of two large fact tables, the queries are becoming very slow. And then the dynamic tables, typically while querying the database, we might have to do a lot of processing. And in traditional data warehouses, we tend to create too many dynamic tables in the middle, and then we actually use it while querying. Even the DDL, those dynamic table creations, also very complex. So the management of those dynamic tables also becoming very complex. So, And then most of the times we misuse the DB in terms of making it as using it as a cache or messaging queues, which is not because the data warehouse system itself, or the users of the developers of the data warehouse system are typically RDBMS experts. So in case of a usage of cache or messaging queue, they tend to create a new set of tables which will serve the purpose of a cache or messaging queue. But this is a kind of an entry pattern for a data warehouse. And then typically the Java developers or Python developers, we have seen in the past that they tend to use a ORM since it simplifies the data access towards the data warehouse tables, which is that because here that ORMs are not optimized very well enough to access huge amounts of data, millions and billions of records. So the development paradigm also giving some kind of issues, and then it is going against the SQLs. So with this, I will complete the BI overview. So I will try to give a short overview on the industry trends. Let me go to the slide. Okay. So this is a hype cycle for the big data 2012 from Gartner. It's from July 2012. If you see, there are a lot of tech happening in the big data over here. So the NoSQL database management systems are in fact falling under, started falling under peak of inflated expectations. And also if you look at in-memory data grids, they're also falling under delusionment. So we have a lot of scope for improvement and as well as also using the big data in the BI tools, because they serve the need of large-scale databases, and they help us actually to avoid some of the problems that we are facing with the SQLs. And then here we talk about the opportunity heat map by industry. So if you see the banking and securities, they have huge amount of opportunities in the area of volume and velocity of data. And if you see the communication industry, you see a lot of things on the volume of data and as well as the hardware and software. And then if you see the government has more potential, you can see on the velocity volume of the data, variety of data, underutilized data, and as well as hardware and services. So the many industries are looking forward for the big data opportunity, and BI will play a very critical role in actually converting the big data into a or monetizing the big data into a meaningful insights. So this shows trends in Google with respect to NoSQL. You can see that NoSQL trends have been increasing over here, the blue line, and the red line showing the RDBMS trends. And if you look at the job trends, so the NoSQL job trends have been steadily increasing from Jan 10th, 2010. So there is also a Jaspersoft Big Data Index, which generally gets published once in a year. So in this talks about big data downloads. There seems to be having a increase about 92% in 2012 so far. And then in Jan 2012, we started getting the popularity for documented stores. Okay. And then key value stores and big data, big table stores fall under second category, where with 20% and 19% of the demand. And in 2012, the big data, the MongoDB, in fact, scored around 70% of the demand. And Cassandra almost grew about 100% in May itself, May 2012 itself. And Hadoop and of course Hadoop and Hive downloads are constant over a period of time from 2011 to 2012. So with this, I will also give some short introduction on the NoSQL. So NoSQL, basically the abbreviation acronym stands for not only SQL. So primarily the definition states that it's primarily a next generation databases, mostly addressing some of the points like being non-relational, being distributed, being open source, and being horizontally scalable. And then one of the most important principles in NoSQL is the eventual consistency. I'll also talk about that in the next slide. And apart from that, the key features are asynchronous replication and sharding. So asynchronous replication will help to replicate the data across multiple servers without user intervention or client intervention. And then sharding will help us actually to distribute the data into multiple nodes in a cluster. And then elasticity, scaling up and scaling down is pretty easy with the NoSQL data stores. They are shared nothing architecture, so we don't have to invest on expensive shared storages. And the two principles, space and cap, I will be talking about in the next slide. The cap theorem basically talks about cap C for consistency, A for availability, and P for partition tolerance. So the cap theorem states that you can pick any two of the three. So that means if you are picking consistency and availability, then we need to compromise on the partition tolerance. And if you are picking consistency and partition tolerance, we need to compromise on availability, and same as for availability and partition tolerance. So basically consistency means we need to have a common state across multiple nodes. And availability means system is designed and implemented in such a way that it allows to continue to operate even if one of the node goes down. And partition tolerance includes that if you have a huge network of nodes, dynamic and addition of those extra nodes will not harm the existing already running system. The theorem says that basically available indicates that system does guarantee the availability in terms of the cap. The availability in cap is applicable in the basically available. And the soft state indicates that the system state may change over time without even an input. This means then, for example, if the data is replicated and if you are modifying one of the value in one of the node, the other node will get modified. The data in the other node, the replicated data in the other node gets modified after a certain amount of time. Okay. This also indicates the eventual consistency, so that the consistency will be arrived over a period of time, so that because the replication takes time. So there are a couple of NoSQL storage types. One of the fundamental one the initial one is the key value or tuple kind of store. There are multiple vendors in this area: Redis, Voldemort, Tokyo Cabinet, and Dynamo. And then the columnar stores, we talk about Hypertable, Bigtable, HBase, Cassandra, React. This is not a complete list, of course. We will be talking about some of the few examples. And then document-oriented store is primarily the CouchDB and the MongoDB. And then graph-oriented stores include Neo4j, FlockDB, Infinite Graph. And if you have object stores, where primarily the Gemstone and Oracle Coherence are typically examples of the object store. The XML databases exist, and Oracle are two XML databases. If you go to this NoSQLdatabase.org, you'll find about 150 plus NoSQL DBs listed. So we need to be very careful in picking up also a right NoSQL for a particular BIR or for a particular application. Okay. So the benefits of the NoSQL includes horizontal scaling. So basically adding nodes should never be a problem. So the partitioning of the data should be done, and the data needs to be redistributed to other nodes in a more seamless way. And then the data schema is basically it's a schemaless. So even if you take key value store, documented store, graph store, all of them are basically the schemaless. So the idea is that we don't have an overhead of migration of the schemas when we are actually introducing a new version of the databases. And also the development becomes faster. And also no limited overhead of relational constraints. So we don't have to really have relational constraints. Typically we don't have at all relational constraints. But of course we can introduce some other relational constraints in, for example, a graph database. But I would say we can actually leave this overhead to applications which are actually accessing the data. And the large tables. So one of the more important behavior of the NoSQL is that we can have columns ranging in thousands. Okay, so especially the big data, big table stores, they actually can store lot of tables, lot of columns. And then this helps, in fact, the longer list of columns helps in denormalization of the data warehouse. And then the faster data ingestion. So because it's a sharding, the data goes pretty fast to multiple nodes in a distributed way. And the other set of NoSQL benefits are basically here we talk about distributed reads and writes. If you look at traditional RDBMS and NoSQL, if you see the picture, the distribution of this data writing is happening in such a way that the client is using the sharding technique. It will automatically distribute the data to appropriate node. So in case of RDBMS, the RDBMS server have to take care of this distribution. And then the batch processing can be done very fast with MapReduce, and runs on one of the most important behavior in the NoSQL is they can run on commodity hardware. And the plug and play and dynamic clusters is one of the most important features. And the development becomes quicker because schema free behavior, and as was also because we actually don't have the SQL there. So SQL becomes more complex. Okay. The next one. So I'll be talking about some of the NoSQL stores, the behavior of the NoSQL stores and features of the NoSQL stores. So if you take a look at key value stores are primarily a big hash table, a big distributed hash table with a unique key and also the pointer to the item of the data. So and sometimes they also get accompanied by a cache, so that we can get a better performance. Keys can be primitive types or objects. So we can also have an object that is actually hashed into a key. And then we can access values only by key. So that is one of the fundamental behavior in a key value store. But of course, some of the key value stores giving some extra features wherein we will be able to even query by values, but the performance is a hit. And because of this, the amount of BA that you can do with this kind of key value stores are typically limited. And we can actually write specialized applications that works only on top of the keys. Okay, so maybe we can go for a, let's say, composite type of key wherein we will be able to do a bit of multidimensional analysis, but primarily they intended to create a specialized applications. And the initial philosophy came from Amazon's Dynamo paper. So the next one is the documented oriented databases. So basically the documents are version documents. They will be stored against a key, and also we can retrieve and store these documents in multiple formats like JSON, VSON, or XML documents. Sometimes NoSQL databases in fact classify the XML formats as XML documents, XML NoSQL stores separately. But most of the NoSQL stores will support JSON. And this is also schema free. So the next one is the column stores. So each key is basically in this case associated with many columns. So a column is defined as a tuple that contains a name, value, and a timestamp. And the column family, basically here it's a group of columns that are stored on a disk together. So if you are querying a column in the store, then we need to consider these aspects, whether the column belongs to a particular column family or not. And then row, basically it identifies a specific group of columns in a column family. And then there is a super column also, I think Cassandra talks about it. This is the column that has multiple columns, of course. And one of the major important feature of columnar stores is that they are very excellent compression of the data, because you are storing it a column-wise data, and based on the data sparsity, the compression might be better. The other variety of the databases are graph databases. They are based on the graph theory. So that means they consist nodes, and each node contains properties, and node contains edges which are connecting the other nodes. And in fact, some stores like Neo4j even exhibit ACID transaction capabilities like RDBMS. And one of one of the primary argument of the NoSQL, this graph databases, is that they are whiteboard friendly. So you can actually write your concept on the whiteboard as a graph, and I can actually create the same schema in the NoSQL graph databases. Now, in the next few slides, I'll be talking about how we can integrate NoSQL into the BI. So I will be talking about a couple of integration patterns. So here I have defined around 7 patterns. So the NoSQL entirely, NoSQL as a data source only, NoSQL as an aggregator, NoSQL as an operational data store, and NoSQL with BI embedded OLAP. So I will be talking about all these 7 in the coming slides. Let's take the first one. So NoSQL entirely. So here the idea is that the NoSQL is one of the data warehouse element. Basically, it's the primary data warehouse element, which is actually talking to the business intelligence. So here, since the NoSQL is limited in terms of the ad hoc query capabilities, we will not be able to build a generic purpose BI, but we will be able to build application specific or purpose built business intelligence suite, which can address some of the or one of the department's fundamental needs. So the connectivity, since there is no standard connectors to NoSQL, we will have to go with a native connectivity, and also based on the type of the NoSQL. For example, if it is a columnar storage, we might be able to do more flexible BI, and if it is a key value store, obviously we will be limiting to a specific domain. Okay, and also the metadata and semantic layer can also be part of NoSQL itself, since we are using a NoSQL. And the second pattern is a NoSQL as a data source only. So here we talk about, it's a kind of reverse pattern to the previous one. So here we talk about the NoSQL feeding the data into a OLAP or analytical DBMS, and then the business intelligence is talking to the DBMS. So in this pattern, so we use the traditional ETL. The ETL will have the native connector to the NoSQL, and which will feed the data into OLAP DBMS. And the BI will, as a traditional BI, it can actually connect to the OLAP using the standard SQL connectors and do multi-dimensional analysis. So the next one is a NoSQL as aggregated storage. So here we talk about connecting both analytic DBMS and as well as the NoSQL to a BI suite of applications. So here the analytical DBMS will feed the data into NoSQL using the ETLs, and the NoSQL is typically contains the aggregated information. So even the aggregates can be denormalized before they put into the NoSQL, and the temporary data, the raw data or transactional data, which can be also directly connected to a business intelligence application. So the dashboards can be sitting on top of the NoSQL data, and drill down reports can be sitting on top of the analytical DBMS, so that you can actually drill down from a dashboard to the reports. The next one is the NoSQL for operational data store. So here we talk about using the NoSQL as an operational data store, and using a analytical DBMS as a aggregated data store. So here we of course use the traditional ETL, but the difference between the previous patterns is that we will allow the NoSQL to connect to the BI directly, and as well as also the BI talks to the OLAP. In this way, there is a multi-dimensional analysis on top of the aggregated data, and as well as drill down to the raw data based on a particular key. So the limited access to the raw data, but a flexible access to the aggregated data. Now we talk about the BI with embedded OLAP here. So what this means is, of course, if you look at an example of Pentaho Mondrian or Oracle Hyperion, so these actually have an OLAP server built in. Some of the BIs in fact have a OLAP server built in. So we should be able to connect NoSQL directly to the OLAP servers, and BI, of course, as since we have a multi-dimensional OLAP server, BI can do ad hoc analysis and multi-dimensional analysis, and then also connect to the NoSQL with a native connectivity. So NoSQL will still give a limited ad hoc capabilities, but we will be able to use OLAP for a multi-dimensional ability. The next one we talk about using NoSQL as a cache. So here we look at using either an RDBMS or NoSQL as a data warehouse, and we have an extra cache sitting on top of this data warehouse. We have a specific cache loaders which will load the data into cache, NoSQL cache, and BI will be talking to the NoSQL. The primary purpose of this kind of pattern is that BI will be used for doing data exploration or interactive analysis by searching the data in the NoSQL. So the NoSQL that support some type of full text search are more primarily the candidates for this. The next one is using the NoSQL as a semantic layer or repository. Here we talk about regular data warehouse or a NoSQL based data warehouse, which is talking to BI, but the BI actually having the repository based on the NoSQL store. That means the semantic layers, that means the metadata, and as well as the BI artifacts will be stored directly in the NoSQL, which will give more freedom and as well as the faster access to those reports. And as and when the BI repository grows, we can also scale the NoSQL. Next, I will talk about the NoSQL modeling patterns that are applicable for the BI landscape. So basically, in the modeling, some of the typical considerations that we need to do is we need to start the application model and the NoSQL modeling from the application needs. We need to see what are the use cases that we need to support. Based on that, we need to choose the NoSQL store, and as well as based on that, we should actually also define the model patterns. And also, we should understand how the data been accessed. So we should have a very good understanding of data query algorithms. And also, we should be very careful with the type of the NoSQL that we select, so that we can apply the appropriate modeling patterns. So some of the modeling patterns are denormalization, which is a general concept that we also use in regular data warehouse. So here, typically, if you look at traditional data warehouse, we have a time dimension, we have a fact table holding the time information, and generally we link them by a surrogate key. So the time dimension will be separately populated in a dimension table, and the fact will be actually linked by a surrogate key. But this is actually a relational model, which most of the times introduce lot of trouble in accessing the data or querying the data. In case of denormalization, the proposal is that we actually also bring in the time element into the same table, rather than actually using it as a separate table. And the application can handle the appropriate filtering and query of the time. And then the next one talks about the aggregates. So especially here, the nested document structures, they will help us to reduce many-to-many relationship. If there is a document data store, and if we're actually representing, let's say, a person, and for example, an employee and employer as a different documents, we have troubles in actually accessing those two together, because the reason is we have to link them in the application side and access them. But instead of that, if you nest them, we will be able to access them with a one single call. And then application side joins. So here we talk about joining on the application side rather than joining on the database data store side. So this is typically more since we have since there are a lot of technologies to do distributed computing, we should leverage the application side joins in order to actually access the data very fast across multiple document stores. And then atomic aggregates. So here also the idea is that we should here we are trying to introduce some kind of atomicity when modifying a particular set of documents. So the idea is that we create an aggregated or nested document structure. So in case, so that we can avoid multi-value updates in multiple documents, and then only focus on a single update on the single nested document. So it will be one transaction, and then we can achieve the atomicity accordingly. And then next one talks about the dimensionality reduction. So we should be able to have There are multiple techniques available, in fact, to map a multi-dimensional data into a key value model. So we should leverage them. We should ensure that the dimensions have been reduced and so that the joins are reduced. And then one of the typical scenario is that most of the NoSQL data stores, they will not support indexing. So indexing will help quicker access to the data. So here in this case, what we are trying to say is we maintain a separate indexing table in a different NoSQL store, and then this can allow us to do a faster access of the data. And then one of the most common use cases in a key value store or any other NoSQL store is the composite keys. So that will help us to do a multi-dimensional query. And then I will also slightly talk about the semantic models here. So semantic model, as I was explaining, it's primarily a business representation of the technical data in the database, and it sits between data and end user so that it can translate the database structures into a meaningful business objects, and it helps to run the queries against appropriate stores or databases. And then also it serves as a single source of truth for the business users, irrespective of number of data sources or variety of data sources. So here I propose that the semantic models can be modeled in NoSQL in two different ways. One is using the graph NoSQL stores, or the other way is actually using an RDF semantics in a documented data store. So this will help us to actually model a relational style database in NoSQL store, because traditionally most of the BI repository or semantic models are RDBMS oriented because they are more relational in nature. So even this can be modeled with a graph databases here, and that can also help us even to achieve some level of ACID behavior. So the summary is that so we should when we are looking at BI and NoSQL, we should look at first of all evaluate the appropriate NoSQL store so that we fulfill the application needs. And we also have to remember the fact that the SQL is not going away. So SQL needs to be kept because ad hoc query is a serious limitation in NoSQL stores, and SQL will still remain there to serve the needs. And the future BI is expected to have a polyglot persistence. What this means is we might have both NoSQL or multiple variants of NoSQL along with multiple variants of SQL databases in the same BI suite to serve different BI use cases. And then also the modeling is very strongly depending on the application needs and as well as the type of the NoSQL stores. So with this, I will wrap up the session. So I think it's time for Q&A. So I will look forward for some questions. Okay, so one of the question is how predictive analysis are carried out on NoSQL DBs. So the predictive analysis are tightly linked to the data mining and machine learning kind of technologies. If you look at plain vanilla Hadoop stack, we have a couple of libraries on top of it, a couple of packages on top of it, which will help us to do the predictive analysis. For example, we have a package called Mahout, which will help us to run the machine learning, and also we have R language, which is also integrated to many of the NoSQL stores, and even most of the commercial and open source data mining and predictive analytic tools nowadays can integrate with the NoSQL databases and understand the data for doing the predictive analysis. Are there options available to host the BI on cloud PaaS infrastructure? Yes, it depends on the way that you want to look at it. So most of the BI tools, if you ask me, they already been offered as a kind of a software as a service infrastructure, because BI is considered as a software, and most of the vendors offer as software as a service. If you're looking at a PaaS infrastructure, maybe you are looking at building your own BI applications and using the existing PaaS infrastructure. There are a lot of PaaS infrastructures. From the VMware, we have Cloud Foundry, and there are other also available like Heroku, which will help you to deploy, develop the applications around the BI. Please give an example of an application of NoSQL as a data source only. Okay, so what happens is when we are developing a BI applications, BI is a massive project. So what we try to do is generally is we try to connect from the BI to one of existing applications, and we try to get the data. So some of the applications in this case are NoSQL based. So what this means is you have an application that you have a small application that gives you data, and that is built on top of the NoSQL. We should be able to actually integrate that NoSQL source as a data source. That means we need to use the regular traditional ETL tools to connect to the NoSQL sources and then get the data from there. So when you say NoSQL as a data source only, because data source resides outside the infrastructure of the BI, and we should be able to connect from the BI. So this is what is the intention of this. Okay, what is the main difference between SQL and non-SQL? Good question. So SQL is developed as a standard for querying the relational database stores, and NoSQL is not really a standard, but it is actually meant to be defining. Let's say initially started as a distributed hash table, which has both persistent storage and as well as in-memory storage, and there is no standard for accessing the data that is residing in NoSQL databases. So maybe it's still an evolving phase, but for now, yeah, we don't have a standard. But SQL is a standard, and which will help you to actually deploy. SQL is a standard which will help you to query the relational databases. Can you please specify a few open source BI tools? Good question. So we have, if I remember correctly, there's an open source BI tool called Pentaho, and there is another one called Jaspersoft, and one more called Spago BI. I think more or less each one of them has a different kind of adoption in the industry, and you need to choose what is best for your needs. If I want to start with NoSQL, is there a good starting point? Start with the NoSQL databases.org, and then maybe if you also Google, you'll find a lot of interesting tutorials on the NoSQLs. Typically, as you see the Jaspersoft BI index, the MongoDB seems to have catching up a lot of momentum in the last 1 or 2 years. Maybe you can even start with that. Okay, I think I have completed the list of questions that I have received. Okay, so one more. How can I implement XML data in NoSQL? Good one. There are special kind of NoSQL stores that stores an XMLs. you wanted to look at it. There are some stores are coming from Oracle and also an Exist. There is another source. So if you look at the NoSQL database.org, it talks about few types of NoSQL stores that help you to store XML directly. And even graph databases are also a good source of storing the good target database for storing the XML data, because XML data is hierarchical in nature. How can I connect data source in NoSQL? So basically, each NoSQL has its own API to connect. So some of the NoSQLs even support Thrift-based APIs. So you can also use a Thrift interface to talk to the NoSQL. But I think you need to look at a specific NoSQL, and then the API talks about how to connect to that, and depends on the language. So if you want to connect in Python, you have a different API, and if you want to connect in Java, you have a different API. And in case of the BI tools, open source and commercial ones, they also come up with adapters that can directly talk to the NoSQL stores. Persistent storage, does it apply for an XML file? Yes, of course, but the data storage, the way that gets stored into the NoSQL, it depends on the NoSQL storage. But you can store the XML files using XML-based NoSQL stores, or maybe even a documented-oriented store or a graph database. Which is the best NoSQL DB? It's a tough question to answer, but the thing is, you need to look at what is the kind of use case that you want to develop on top of the NoSQL DB. If you are dealing with too much of document style data, then documented oriented databases will help you better. And if you are looking at too much of a hierarchical data, then maybe you want to look at graph. And if you want to look at simple key value kind of databases, then obviously you can look at Redis and then also memcached, this kind of data stores. But of course, you need to define in terms of what kind of implementation that you want to do on top of it. Okay, there's one more question that talks about I have installed CouchDB on my machine, but it's not working properly. What could be the problem? There's a very specific question. Maybe you need to look at the documentation of the CouchDB and go through the facts or go through the community forums of the CouchDB and to understand how to fix it. Is it possible to migrate all database to NoSQL from RDBMS while keeping the application as it is? It is not very trivial to do this, but there are some kind of, because it depends on the kind of queries that you have used on top of RDBMS. If you have a kind of complex structured queries that you have written on top of RDBMS, they may not work in the same way that on top of a NoSQL. So some of the NoSQLs in fact support SQL-like syntax. They're not really SQL, but SQL-like syntax, which are not the same as RDBMS SQL. So both the applications and as well as also the database have to be changed. So there's one more question. What kind of entry-level roles at organizations based on NoSQL? I'm not sure whether I have got this question right. So maybe you can repeat that. This is Shruti Reddy. Yeah. Good. Do we have any more questions here? Please specify NoSQL data structure. The data structure is depending on the kind of data store that you use. So as I was mentioning about different types of data stores, the data structures varies between those data stores. So being it's a key value, graph, documented oriented. So we need to vary the data structures accordingly. So what are the restrictions of a NoSQL database? Very good question. So we talk about the advantages of the NoSQL heavily, but yeah. So basically, one of the restrictions is most of the NoSQLs, as you have seen, either being the key value or being the columnar storages, being graph databases. Most of them are typically, most of the types of stores are typically based on a kind of a key value kind of patterns only. So the amount of ad hoc coding that you do on top of such kind of databases will be limited because you can give only the key in your where class. Of course, there are some databases which will also offer giving a value in the where class, but the performance will vary. Performance will get degraded. So they work best if you can actually create a key level. So that's one of the things. So the use cases are very much depending on the kind of data store that you use. So, and what we need to look at it is the kind of problems that we are not able to solve with RDBMS, are we able to solve with the NoSQL or not? So, and then introduce the NoSQL in those places where we're not actually looking at suggesting everyone saying that you need to move away from RDBMS and use NoSQL. But we are trying to say that, trying to find out the problems in your BA application and see if the NoSQL can solve those problems, and then put the NoSQL there.
Those were the only questions we had for the day, Mr. Kalyan. I'm really thankful to you for the insightful presentation. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this session would be available on techgeek.com by evening. Thank you all. Have a great day.
Thank you very much.